Conversion of galvanometer into ammeter. Okay, you know that ammeter, it is an instrument which is used to measure the electric current in the circuit. And this ammeter, it is usually connected in series with the circuit. That means if this is my resistance, let's say this is a resistance R, and if some current is passing through this resistance, then I need to measure this resistance by using an ammeter and connect this ammeter in parallel. Okay. So now, if the current passing through the resistance is small, that means the same current also will be passing through the ammeter. If large current is passing through the resistance, so large current also is passing through the ammeter. Okay. But we know, we have seen before that a galvanometer, it is actually a very sensitive device in which it can give a full scale deflection even when the current passing through it is very small. Okay, like in this case, I'm taking the example of current as 5 ampere. So 5 ampere, it is a huge current for the galvanometer. Okay, so when this 5 ampere it is directly passing through the galvanometer, then the galvanometer may damage. Okay, but this ammeter, it is a galvanometer only. So if it is a galvanometer, now the question is how this ammeter can measure the large current without damaging the galvanometer. So we convert this galvanometer into ammeter by connecting a small resistance S, and this resistance S here, it is known as a shunt resistance, and this shunt resistance, it is less than the resistance of the galvanometer, and this shunt resistance at the same time it is connected in parallel with the galvanometer. So by connecting the shunt resistance in parallel with the galvanometer, we get a new instrument which we call ammeter. Alright, so now let us see what is the function of this shunt resistance in this case. Alright, see, suppose this is the current I which is coming from the source, and this current I, let's say it is a very large current. Okay, so if it is a large current, then at this point A, what will happen? This current, right, will split into two parts, right? In one, along this side, current will be passing, and similarly along the galvanometer, some current will be passing. Okay, let us see here that the current passing through the galvanometer, let's say it is Ig. When I say Ig, it means it is the current which gives a full scale deflection in the galvanometer. And this current, let's say it is a small current. Okay. Now, if Ig is going through the galvanometer, then the remaining current which is passing through the shunt resistance will be how much? I minus Ig. Okay. So therefore, by doing in this way, we prevent the galvanometer from damage when a high current is passing through it. Alright. So this shunt resistance, it plays a very important role. That means it allows most of the current to pass through it, and only a current Ig it is passing through the galvanometer, and this galvanometer it will show a full scale deflection when the current Ig is going through it. Okay, so now let us derive about the equations of this current Ig which give a full scale deflection in the galvanometer, as well as the value of the shunt resistance, and lastly about the equivalent resistance of the ammeter. Okay, so it is clearly here, seen here that because these two resistances S and G are connected in parallel, so therefore the potential difference across S, it is the same as the potential difference across G. which means when I see potential difference, right, it is the product of current and resistance. So potential difference across S, it is the current through S, and the current through S is how much? I minus Ig times the resistance, that is S. Potential difference across G, it is equals to the current times the resistance, that is G. Okay, so from here, if you find out S, you will get Ig upon I minus Ig times capital G. Okay, so this is the equations of the shunt resistance. Alright, so if you want to find the value of the shunt resistance connected in parallel with the galvanometer, so you have to use this equation number 1. Okay, now let us find out Ig from here. So if you remove this bracket, you will get Is minus Igs. Right hand side, it is Ig times capital G. Okay, now just Is on the left hand side, then you'll get Ig capital G. Taking this to the right, it becomes plus Igs. Now what I'll do here is I will take common this Ig, and inside you'll have only capital G plus S, or just Ig, it is equals to I, okay, or I'll write like this, S upon G plus S times the current I. So this is the equation which is required to find the the current in the galvanometer, so that it will give a full scale deflection. Okay, now the third thing is we need to find the total resistance of the ammeter, because these two resistances S and G are connected in parallel. So the equivalent resistance in this case, it would be Gs upon G plus S. Okay, I hope this is right. You remember this because we have done about the connections of resistance in parallel. So when you find out the total resistance, right, this is actually the equations of the total resistance. Okay, this is my equation 3. Now this equivalent resistance, it is actually less than the smallest resistance of the ammeter. So in the ammeter we have two resistances, one is S, another is G. But we know S here, it is smaller than G, S is smaller than G. So this equivalent resistance, it would be very less than S. Okay, so please note down this point. Okay, so this is how we convert a galvanometer into ammeter by connecting a shunt resistance in parallel with the galvanometer.